But now it is my great pleasure to introduce today's speaker. It's Dominique Cunin from the Grenoble Valence Art and Design School. So welcome, Dominique. The Zoom room is yours.
Thank you very much, Kale, for the invitation, and of course, colleagues of yours that are here with us. So I'm going to share my screen right now so that everything is working for you to see what I want to share. Also, the keynote I'm going to show you has been uploaded on the website so that you can, well, follow it from your web browser if you want to, because some videos may be a bit laggy, but it can also be used after the speech so that you can go back to the materials I'm gonna show today. So can you confirm me that you can see my screen?
Yes,
It looks like
perfect.
it's okay.
Perfect.
So this is the topic of today, AI text and images generation for the arts. And I'm gonna try to give some statements about self-hosted solutions. So this project, this keynote is part of the AI Secret project. I'm gonna give a few words about this European-funded great project we are part of with Kale and many other colleagues that I could see in the session today. Just a few words about where am I working now. I'm working in this higher art and design school of Grenoble Valence, two sites, two different cities, Grenoble and Valence. You can see that the buildings are pretty different. So I'm mostly in Valence, and today I am in this building with the orange-red metallic part on the facade, and the other one is most a bit more older type of traditional Beaux-Arts place in Grenoble. So the map can help you figure out what is the location in Europe and also in France. So the two cities are not so close from each other. It has been, well, we could say, gathered by the government in 2011. So we are one school, but two different sites with two different histories. So we are working together on some point, but mostly not. So a few words about who I am and why I am here now. So I made my studies as an art student in the beginning of the 20,000 years. It was in Nancy, in the northeast part of France. At that time, I learned computer programming almost by myself because I thought that one of the most interesting, we could say, challenges and well, something interesting to do in my life was also to investigate interactive arts and interactive works. So I had to, well, train myself on computer programming to write softwares for the arts. After my, well, graduation, I decided to go on a master level because it was not a master at that time, the graduation I had from my original school, art school. Then it was in Poitiers, another city in France. It was specialized in digital art. Then I went to the PhD in aesthetic science and technology of the arts in Paris. It took me quite a time to achieve it because I become a teacher in universities and art school meanwhile. Then I became a professor in this school here in Valence, in art and design school, specifically in the graphic design department, because we have two different departments, art and graphic design. And usually in France, art schools can also have other departments gathered in the same school. It can be interior architecture, it can be also well, object design, mainly object design, or visual communication. Then after, in between, I became an associate researcher at ENSAD Lab, which is also the place I made a big part of my PhD, in fact, in Paris, Art Décoratif, in the reflective interaction group, where I'm still working at the moment. And I'm in the process of becoming the research head of my school here in Grenoble-Valence in relationship with the University of Grenoble and other partners internationally. So my main expertise is in art and science and technologies, mainly for digital art, also for the tools designing that, well, artists and designers can use, and we call this practice-based research in art and design. This is not so frequent in France, in fact. I know that in the northern part of Europe, it's more, well, usual to have a practice-based PhD in art and design, but it's a slow process in the more Latin part of Europe to acquire this structure to have this kind of researches. So AI Secret is a big project funded by the European Union. It's part of the Digital Europe program. It's led by University of Valencia, and it's thanks to this project that I'm here today, and I'm very grateful for this team. So the idea is to build a curriculum for a master about how AI can enhance skills of the future for the coming professional in the world in the triple transition. So it's not just the art, but it's a large variety of works and professionals that we are trying to involve in this future curriculum. So my proposal in this project from the very beginning was to, well, use knowledge, tools, and skills, and say that it's the fundamental part of what we are doing in practice-based research in art and design. So the very first thing I just tried to expose to my colleague a few months back was this list about what self-hosted AI tools means and how we can involve these tools in art and design creation. So as you can see in the list, it's a lot of different type of skills, mostly technical, but not just technical and technique stuff, critical thinking, design research methodology is the designerly way of thinking is also, well, we could say some more abstract knowledge, but it's also very connected to how we can use these new technologies as creators and what it means for us. So we must stay critical in front of this, but to be so, we must also use them. So all this knowledge it has to, well, come from somewhere. So the main topic of this speech is summarized here. How can we make use of Gen AI as artists, which is a broader acception of the word, of course. And I think we need a clear understanding of what are these tools and what they are made of and what kind of artistic production they can foster. It's necessary for us to be aware of this facts. So local or offline self-hosted generative AI can be used, I felt from the beginning, to build custom creation workflows based on open source AI model. So the idea is to integrate AI into the already digitalized workshop, so the atelier of the artists, designers, or creative, because we already have so many tools. For decades, we are using digital tools. So how can we insert these tools today without disturbing everything, but also having something new? So it's not about seeing AI as an evil tech, stealing everything for the arts and making our jobs disappear, which is maybe a reality that still needs to be clarified anyway in the reality. But it's more about also an aesthetically exploration of what the art can are now living, we could say, experiencing. Because in my vision, it's a way of philosophically questioning this new stage of automation. So it's not just the art at the end. Anyway, a real world use case, I'm proposing this journey into self-hosted AI for an art experiment. which is the Pierrot Lunaire. It's done by Mayumi Okura and myself. We are called Acrony as an artist group, duo. It will be held in May of this year, in a few months then. It will take place in Lux, in Valence, which is a national stage theater, and also a place dedicated to the digital art and shows, music. And it's made also in collaboration with the Music and Dance Conservatory of Valence. So, what is the Pierrot Lunaire? It's a musical piece from Arnold Schoenberg, composed in 1912, but it is based on poems written in French by Albert Giraud, who is a Belgian poet. So you can see the years are not exactly the same. The poems are a bit earlier. This is the original aspect of the poems written in French. It's one of the first edition of it. And then we have today this image, this collective memory of what is Pierrot, the clown, the sad clown, that is always very pale with this white face, and also always with this makeup, with these tears that can be drawn in black. So a classic ballet shown us many of these stages. So the sad clown Pierrot image we have collectively is mostly this one. A few informations about what are these poems. 50 poems with a specific organization of the sentences. It's, well, taking back the commedia dell'arte, the figure of Pierrot, but it makes it more melancholic, a moonstruck dreamer. So something like, well, someone more or less insane that is getting closer to, well, not just sadness, but getting crazy, in fact, in the, well, description we have in the poems. So it's very vivid. The language is very symbolic, and we have Pierrot that is really tragicomic. We have also most supernatural elements. The moon is always here, making Pierrot mostly mad in very strange situations. So we have, well, nightmarish vision that are depicted by these poems with a vocabulary that is very, we could say, grotesque also, very bloody. So Arnold Schoenberg got some inspiration from these poems and decided to select only 21 of them and to reorganize them in a new order. And from this, he made a new composition. We are in 1912. It's also after the birth of photographic cameras and cinematography, which means that the art at the time, in the wider acceptance of it, music, as well as painting, as well as dancing, architecture, etc., were already in a transformation period. So these new technology, that was the cinema and the photograph, was in fact making a kind of aesthetic crisis, and quite a huge one. And a few years after the composition of the Pierrot Lunaire of Schoenberg, the First World War was beginning. So what is Schoenberg? You will have, I'm not sure you can hear anything. Do you hear something?
No,
no sound.
No.
So I'm sorry. From the website, you will be able to hear an excerpt of it. So forgive me for not being able to share it with you, but it's a quite abstract music, a bit, it's atonal, and the rhythm is really destroyed, we could say. So in the world of music, of contemporary music, it's a big event. It's very disruptive. And we saw very quickly similarities between the situation in which Schoenberg produced the Pierrot Lunaire and today's situation, where more or less everything is chaotic. We are adopting about almost everything, information, authenticity mostly. We also see that a kind of a variety of wars are already ongoing, even in the physical part of it. Climate change is also depressing a lot, and we mostly imagine apocalyptic, well, coming scenes for the near future. Deepfakes, AI-produced deepfakes are also blurring the limit between what we were thinking like, well, pictures from the reality, from the real world, which are now different realities, in fact. So this global representation crisis, in my sense, is also a deep philosophical reconsideration of the fundamental act of creation. And this is my filter, I could say, to think about AI and, well, self-hosted AI in the creation and what it is making to creative people. So at the very beginning, the ideal scheme we had to make something for this project that will be on stage, played by professional musicians. We will have 40 minutes because the whole piece is just 40 minutes long. And so we are supposed to accompany, to show something in the back of the musician, to show images, videos, well, visual stuff, and also text to accompany this. And so the idea was to take some sound live to generate new poems with LLM, but we could say, again, self-hosted LLM and maybe fine-tunes. We are gonna go inside of it. Then also to produce images from the poems. So the poems become prompts to craft also some new images. Then from the images, produce short videos, and then to show it on stage. So that's the very first scheme, workflow we imagine. So the first step was for me to try to understand how we can use LLMs, not online, like ChatGPT or the most equivalent of this, Gemini, etc., but to download models locally and then to use them in a local chat system or also in a custom-made programming framework, a small application. So I used, and I'm still using Olama, which is an application that you can download on your own computer and that will help you to organize your models and to use them. So this is where I discovered, like other people involved in this area of practice, Hugging Face, which is a kind of GitLab, a big repository with models that are shared online. And so you have the possibility to explore different types of models that you can download and then use depending on the license that you have. Most of them are open source, but it depends on which part of the model are open source. We'll go further on this a bit afterward. So using these models, there is also a new, we could say, technical world that is opening when you just try to figure out what it means to use these models. So this is just a small part of the vocabulary that we had to learn and try to figure out what it really means. So what is an LLM? Okay, we more or less know it, but how do you use them? And what are the lexicon that is very important for us to acquire, to be able to read and to understand the communication, the documentation, sorry, that you have to read to learn how to use these models. So we have plenty of resources online to do this, but it takes time. So original poems go through, well, are the base of a fine-tuning of a local LLM, and from this, we can generate new poems. So this is something that you can find in, on the web, what is an LLM and how you can fine-tune it with this low-rank adaptation technique, which is now very well known, but that still it needs some time to acquire the required skills to make your own fine-tuning system. So here, what we had to do is to gather all the French version of the poem, which was pretty easy, and then to craft some potential prompt from it, and to recreate entries inside this kind of dictionary file, a JSON-L file, that will be used to make the training of the LLM locally. So as you can see, it's a kind of, we could say, well, software engineering part. So you have to craft the potential prompt, and here you can see maybe the small signs that we can use to make tags and say, for example, that Pierrot Lunaire and Albert Giraud will be some specific words that should be recognized with more weight, we could say, when a user will write a prompt. So after that, I made many attempts, but more recently I tried to use this MLX, which is a technology that is proposed by Apple on the Apple Silicon chips. So you have to use Python mostly. So if you don't know how to use Python programs, well, you are in trouble. You have to learn this first. Then once you understand it, you have to learn every small parameter that you have here in the command line. And then you can have, at the end, a result, which is you download an open source, more or less small LLM. Then you do your training yourself with your prompts, with your own data set. Then you have an adapters. And from these adapters, you're gonna make, we could say, a fusion of the original model and your LoRa weights. And then you will have your own model that you will be able to use locally, or that you can share on Hugging Face, for example. So this is a small screencast of a test I made a few days back, just to show you what it means to use a terminal and to generate a new French written poem in the style of Albert Giraud with a pre-trained model that has been fine-tuned with the poems. So most of you won't be able to read the French, but for those that are able to, it's not so bad. It's pretty nice, in fact, but we still have works to continue on it, to be closer to the structure of the poems. But we can see already we have 4 strokes and 5 sentences here, which is the original structure. So it's pretty efficient. Yeah, so the next part was to engage in images generation and video. So to use this, it was pretty obvious after some research that Comfy UI was the tool to go with. Because again, you can download a model from Hugging Face, and if you are, for example, a good Python software programmer, then you can write your own programs or copy-paste a variety of software parts that you can grab on websites. And from this, you will have a generation program that will work But this tool, Config.ui, is very nice to people that are, well, we could say creative builders or makers, because as you can see, it's node-based. So it's still a kind of programming. It's visual programming, but it's very much, it's easier than writing all the lines by yourself because you connect nodes together. So you still have to work about what is behind every node, what is the function of every node. And well, you can go on learning by doing with it step by step. So the first step was to take the French poem and use it as it is, as a prompt, and see what is going to be out from one model, open source model. So you can see the test is not very concluding because all I have is text, unreadable text. So when you tinker a bit with models, you can have this kind of results, or this one. So it's not so efficient. If you switch language, you don't have the same results. If I take the one of the various English translation of the same poem, I have this kind of result. So it's not the same than in French. I don't really know why. I have my ideas, but I cannot explain so roughly why. So it's pretty different. So in fact, the idea, we were quick to understand that we had to fight with randomness, how we can control a kind of entropy, because these models are not very precise. In fact, the link between the prompt and what is going to be out, what is going to be generated by the model cannot be controlled so precisely. So we decided to make a new step, and if we cannot use the poems by themselves, maybe we can use description of scenes that comes from the model, and this has been done with an LLM that has been fine-tuned with the poems. And so we have this text that is longer, but that is also a kind of description of the picture that we would like to have. So as you can see, it's not very precise. It's not like a cinema director that is stating to each person into the stage to be at this precise place, to have the chair, the table, this kind of lighting, etc. But you can also do that because nowadays models are more or less working like that. So you can build this kind of script prompt like a movie director, but we did not want to have this precision at the beginning. So that's one example of the global process. So you have the original poem, you convert it 1, 2, 3 times, then as a human also you change a bit the text, the description, then you can make image from it. And the part afterward, you can use your image and use another workflow that is dedicated to convert to the animation of existing image to a small video. So you can make move the images you generated, and all of this is made by AI that are working one after the other. So here are some examples. So again, if it's a bit laggy because of Zoom sharing, you will be able to see these examples on the web version. And now I'm gonna show you several examples of all the pictures we made from this workflow and some of the videos that we could make from it. So this is the first poem. I found the English translation so that you can have some idea of what is going on in the poem. So the wine we drink with our eyes, which is a strange vision. So it takes these shapes. It can take also this one with someone that is drinking, obviously. So depending on the description text we produce, we will have completely different images that we get out from the models. Ivresse de Lune, again, it's more or less the same, not the same vision. So this is a video where I tried my best to make the glass having the drink coming to the face of the person. I never could achieve it. The model never accepted to make flow the water on the face of the person. So I made tens of this attempt without success. So this is also the chaos part, we could say, of his techniques. And sometimes it can be also very frustrating because you just cannot have what you want, which is part of this limitation, I could say. Another one, Colombine, the second one. It's a scene that is more gentle, we could say, more smooth. So we have, of course, something different. The poems are very, sometimes bloody, sometimes ghostly. So the images are very symbolic. So for people who knows symbolist painters like Odilon Redon, Arnold Böcklin, well, this kind of area people, it's a bit before the surrealism, but we can feel a bit that this kind of dreamy, nightmarish images are not far away from the idea that the poem is trying to translate. So yeah, Colombine is in the moon. And Pierrot, which is never always the same person, because the generation makes propositions that are always different. It's fine to us to be out of the usual white painted face of the sad clown that we know. We don't want to be that much in the stereotype of Pierrot. So Pierrot Dandy, another kind of picture again. So every time it's more or less the same process. We have to produce many different pictures and then to select these pictures. So sometimes we can select the pictures and then from these pictures try to, well, go deeper in the aesthetic of it, in the structure of it, so that it can be closer to the idea we have from what the, well, model gave us at the beginning. Because most of the time, we don't really have a pre-made image of what can be the representation behind this kind of poems. Of course, everyone has his own way of imagining, having inner pictures in the imagination. But it's very interesting to see that depending on the description and every small step in which you maybe change the prompts and some parameters we are going to speak about in a moment, you will have a different composition, you will have a different, well, color structure. Here, as you can see, we are using the, well, middle end 19th century photographic style because it fits with the era of the composition of Schoenberg. So it seems, well, natural for us to stay in this aesthetic. And the tension that is, well, coming from this high-tech AI system and this old-fashioned aesthetic is a part of what is interesting us a lot. So again, here, something that is more about a dance in a huge hall with ghosts dancing and, well, bloodshed on the floor. So this is what is depicted by the poems, and then the description is more or less close to this image in the strong term, we could say. So making it move is always something very funny. Sometimes it can be also a struggle because, as you can see in this particular example, sometimes the model has what we call usually hallucination. So here the space is broken by the model, which is pretty interesting also. We can use and we will use these kind of pictures because it's not what we are waiting for. Usually, we just imagine that we are going to have a usual, well, film coming from the picture, but we have something else sometimes, and we cannot really, how can I say that? We are not aware of what is going to be spit out from the model, and this kind of surprise can be enhancing our creativity precisely. So here's the sick moon. Yeah, death is coming stronger and stronger the more we go far in the numbers of the poems. So here maybe you saw that I'm writing here the model name. I'm going to explain why. Each model can be quite different from each other. And sometimes we have also base models that can be refined by the creators of the models. It can be refined by yourself. It's also called LoRa. It's the same technique, but it's not using text dataset, but image dataset and also text. So it's the difficult part, and we are gonna dive inside these techniques in a moment. So I'm gonna speed up a bit because I have plenty of these. And you will be able to check online afterward anyway. So this one I'm gonna stop a bit because in the poem, the description is the one of Pierrot that is on the floor, kneeled on the floor, and his head is being cut by the moon. So it's pretty violent and bloody also. So we have this kind of, well, pictures that get out from the model and the description. But the funny thing was trying to make the head being cut by the moon. It's not easy at all because usually we don't have so much videos that have been used to train the model, which is one Chinese model, with people that have their head being cut. So sometimes you have this effect, or you're not really sure of what is going on in it. So after something like 15 attempts, I finally managed to have something that is more or less close to a guillotine. But even using the word guillotine, it was very difficult to have the head being cut. And this is the closest result I could have for this scene. So again, every model is not made to produce everything. So we have also to be aware of it. And sometimes the limitations are not just about, well, creativity, but it's also, we could say, a kind of censorship, which makes sense in different aspects. But, well, sometimes for artistic reason, we need to go further and beyond these limitations. Yes. So I'm going to speed up a bit. Nostalgie, some very interesting walls. We could say not really destroying, but crumbling. The models are different. So depending on the models also, the way the pictures are gonna be used or evolve in time, we will be very crazy. And it makes us, well, think about new scenes. This one is also very interesting because we just ask to the model to take the camera and go forward. So the model is just building up what was not in the original image, which is pretty strange to see because it was generated. So in fact, another model is just continuing the generation of another one. So it's a real workflow between models. And another thing I wanted to show you more precisely is what is called refining. Because when you produce one picture, you can have some, we could say, low quality one. Then you can use another workflow to refine it with, well, models that have been trained to give more details in your pictures. And sometimes it will just make up new objects inside the picture. So you can see the difference between the three steps, I have here. It can go too far in making things that are not here and that are not relevant for the picture or for, well, what we want to have. So this one is a bit more violent again. And the scene depicted in the poem is also very rude, very hard to see. So we have this kind of images where everything is more or less melt between, well, monsters and, well, fire. So again, surrealistic vision, more or less horrific. This one also interesting because we have really the vision of someone that is knitting, and we were surprised to see this video. So we are using diffusion models, which are one kind of model we are using to produce images. It's the most mostly used, the most widely used type of models to generate images. So I'm gonna try to dive a bit inside these techniques. So the idea is to have text that will guide, that will orient the generation of images. So we have this text that it should be tokenized. Then we use a specific model we're going to speak about, which is called clip. And all of this is going to make what we call conditioning. And then the idea is to have noise, so an image made of random pixels, and to denoise this noise, guided by embeddings, and to have a result, an image result. So for those who don't know what is tokenizer, how to tokenize a word, we have several techniques to use it. So one sentence can be tokenized word by word, but it can be also arbitrary. Some models are using this kind of tokenization. And from this, the idea is to connect the parts, the tokens coming from the text to images parts. This is where this contrastive language image pre-training, which is CLIP, comes into play. It's a neural network model that is built with connection between images and captions, description, small descriptions. So it can give you, if you interrogate, if you question the model with an image, you give an image, and the model gives you back a caption. So it was the first usage. But what was impressive with Clip and also with other model diffusion models, it's these zero-shot capabilities, which means it will produce things, give you answers about something it never learned about. So a clip model is made of two parts, a text encoder and an image encoder. So imagine that you have the sentence we had in the previous slide. If you want to connect all the words together with something that is, we could say, synonym or, well, lexical proximity, then you will have this kind of scheme with connection between the words and also a position in space, which will say chamber is far from car, but it may have some connection with window because there is a window also on the cars, etc., etc. So to encode all of this, it will be projected in a mathematical space, which is called an embedding. And the meaning of this, the function of this is to get the semantics. So it has been made with this kind of file, similar to what I've used to train my own open source model. And so you have all the words, then you have the place of the token inside the sentence, and then you have the embedding, so its weights, its values that will say this is where, this is in connection with this, or more or less, and you have the similar words that will help to organize, to connect everything together. So if you take an image, it's almost the same idea. So you will split it in parts, and then you will be able to connect together some words or some sentences to parts of the pictures, and then you will be able to make it with a variety of pictures, and it will consolidate, we could say, the knowledge of the model by training steps. And you can do the same with a vast, very, very vast variety of words and image connections. And from this, you will have a kind of, we could say, a world, a possible world that will be embedded in the model itself. And so it acquire kind of, well, vision, we could say. So these are the usual visualization you will find online. I made the previous one for this, this speech. So you can see it's a little less sexy, we could say, but maybe more precise and more accurate also, how we split the words. It makes an encoding for the text, and then you will connect parts of the image with an encoded version of it, and then you will have well, parts of connected text image objects. So it has been made by OpenAI. It was in 2021, so it's just 5 years back. So it's pretty recent, in fact, this technology. So we spoke about denoising, so what it means, and what means neural networks weight computing. So the idea is, if you have a neural network, you want to make it, we could say, able to denoise an image. So to make it possible, you will take usual image and make them noisy. And then you will make the neural network go through all the steps between what is a clear image, a usual image, and the noise. And every step of noising the image can then be reversed afterward. So if you do that with, again, millions and millions and millions of examples, at the end, you will have something that will be able to acquire all the steps that are necessary to go from a usual picture to noise and the reverse. So online, you can find these kind of schemes that explain it. Cats are very frequent because maybe the world is filled with cats pictures. So it was easy to have open source data set of cats and to well, make them noisy, then denoise them to well, have the learning training data set for the the models. This is an example made with our own pictures, so it's not exactly, you see the same resolution. Sorry. Okay. I have to wait. Sorry. Okay. So it's made with this software, ComfyUI. When we work with ComfyUI, here is a small demonstration so that you can have an idea of the workflow itself. So the idea is to give first the title so that we are not lost. And here, as you can see, I'm giving, we could say, the style we want to have the picture made with. And then the prompt, the main prompt is here, the description. And then you have all these boxes that have specific functions. Each one is dedicated to something. So sometimes it's just a shortcut to modify a parameter of a more complex object, here the sampler, that is gonna produce the image. And then you have also the diffusion model that you will choose in your workflow. You will select it, it will be loaded in your computer's memory, and then the program is going to be executed when you push on the run button. And so it takes a bit of time. You need a quite powerful computer to be able to do it. It takes a lot of memory and also of computing power, but it's still a consumer, we could say, scale computers that you can use. Even, we could say, expensive laptops can be used to have all these computer generation done pretty nicely. And here you can see the steps I spoke about a bit just before, but here with a sampling process that give us an idea of what is the picture at this time of the generation, because at the very first generation, the noise is still very noisy, and the more you go on the steps, the more it will be clear. And here we have another part, which is the refiner I spoke about just before. And the idea is to have this first image, then you send it to another sub workflow, and it will be refined with another model again. And we have the possibility to compare both of the produced, the generated image, to choose which one will be the best, or maybe we should have to generate it again. So Comfy UI is filled with these very practical shortcut tools made for, well, people from the image and video creation world. So it's very efficient and very impressive. It's a very strong, very powerful tool. A word that is very present is latent space. So neural networks in today's AI are made of successive layers linked together. All the parameters that are in the layers are going to make the model at the end. These parameters are what we are calling weights. So it's the value of each neuron inside the network. And the network is not something that is completely randomly made. It's structured layer by layer. And the idea is to, in a way, have an input and take this input and to make it a kind of travel all along the neural network to get to some point. And if the result is not good enough, then a process is made to say, no, it's not enough. So you have to compute again. So the input is taken again, and then the process is redone. And it's in a loop until the process is, well, defined as okay. And then we could say, okay, this is the pathway that should be used. And you should remember this configuration of your own inner elements so that you can use it again in another time. So this is how this modeling and generalization occurs inside a neural network. And this is why we speak about learning. It's just an analogy with human learning. So we have plenty of layers, so we call it deep learning. It's a subset of machine learning. I guess you know all of this, but the result of this is that data are projected in a high-dimensional vector space, which in fact is a set of tensors, big arrays of data. You have this website that is very, very efficient to, well, explore this neural network principles, the playground of TensorFlow. I engage you to have a look to this. Other way of, well, giving images, some representation of what I tried to spoke about. So a model encodes, in fact, billions and billions of possible combination. You have groups of pixels and text that are connected together. So for this connection to be efficient, transformers in 2017 came into the play, and technical invention, an engineering invention. So the idea is to have every data to be transformed, the words, the pixel, etc., into vectors, query, key, and value. And from these three vectors, the idea is to get an attention value, to say, well, this data should be more attentive to another one inside the latent space. That is this embedding space where all the data are embedded, packed together. And so the weights are, well, recalculated from this. And the positioning parameter is giving, we could say, the distance, the maximum distance, and reorganize how the parameters are inside the network. So what is produced is a data space, which is called latent space, in which all the possible combinations are waiting to generate new data. So it's about the training I'm speaking here. So again, the usual schemes that you can see to explain the technical principle of this on the web would be this kind of schemes. Another one, here you can see some different sub networks for sub outputs. So it's very, very large knowledge in engineering that is evolving very, very quickly. So the idea here, as we can see, is that if you have the model, you have to find a way to use this latent space to activate the model, to make a request for a new generation. So we call it inference. It's the model use. So from the latent space, we can extract a proto image. It's not complete. It's just bits of data that are together. And then you can do the reverse path that you took for the training. You start with random noise, and then you will refine it. As I explained already, this is called denoising. And this is where also, of course, prompts, so clip, come into play. So you're going to take your text. It's going to be projected into a third space that will be used to, we could say, question the latent space of the diffusion model. And from this, the data are going to be reorganized and generate an image at the end. So we have to convert all these data into pixels. This is called sampling. And you also can do something, use different algorithm for the timing of each noise reduction step, which is called scheduling. So if you look at the sampler, the key sampler node in Config UI, you can see all of these information. So the model that you're going to use, the diffusion model you're going to use, the positive prompt, what you want to have in your picture, the negative prompt, what you don't want to see in your picture, a latent image which is ready to be, in fact, filled with noise, and then to be denoised with a number of steps. Here it's 20. And here the sampler, the algorithm that is used to convert abstract data into pixels. And you can see also the name of the algorithm for the scheduler. So as a user of the models, I have sometimes the feeling to be in front of an ocean of potential pixels trying to fishing for good imaging with prompts and trying again, and again, and again. It can be very, very long. So this is the way I'm feeling sometimes. So generate data that are not present in the first data set is the most powerful feature of these neural networks, because all the images we are producing are not really as they are already in the dataset. They are being generated. But of course, they are potentially already existent in the model. They maybe are already here. So we could say that we are not really in a process of reproduction, but more in a highly sophisticated remixing of what has been trained. So it's the data set. So another way of thinking about this is that with large models, diffusion models, we can say that images created by humans through history serves as the training data set. So we are making remixes based on humanity's visual heritage. So maybe it's close to the dreaming process to some extent. So this dreaming vision is shared by a huge number of people around the community of Gen AI. And if you go to Civit AI, this pretty famous website where you can download plenty of, well, they call it checkpoints, but also, well, it's just diffusion models and LoRa's and styles, etc. You can see Dream Shaper, which is coming from Stable Diffusion XL. It's a trained, specifically trained checkpoint of SDXL. So this vocabulary of dreaming is very common, in fact. And with the Pierrot Lunaire, we want to make machines that produce nightmares. So some example, quick example of the denoising to show you a bit what it means step by step. So it can be, you see, very, very blurry at the beginning. Then the more you go, the more it will be efficient, clear, precise. Oops, sorry. Guidance is very interesting also. The classifier-free guidance, which scales the creativity and adherence to the prompt. If we see in practice what it means, a low value is supposed to be not too close to the prompt, and the higher value should be very close to the prompt. That's not, it's just an explanation that we find all around in the, on the documentation around the websites dedicated to this. The example here shows us some reality of it, but only a part. The more you give a higher number to the CFJ, the more your picture will be constructed, in fact. But sometimes it can be too much, and it will produce things you don't want to have. Your picture is going to be sometimes, we could say, overworked, over-denoised, and so you can be disappointed by the result. So it's always a parameter, small parameters play to find really what you want. So to learn all of this, you have the possibility, of course, to go to Civit AI education pages, which is pretty nice to, we could say, break the ice, to go and find the main concepts and technical vocabulary that is used and that you need to acquire to be able to understand these tools. Because without it, you are just, well, trying to do some things in a, we could say, in the fog. You cannot see anything and you just try and error, but you cannot organize anything. So open source AI for us is very important, of course. We had already some very inspiring discussion in the AI Secret project about this. So of course, you are supposed to be able to use the systems, to study them, to modify them, and to share these systems freely without authorization, permission from the creator. And this is not so easy to find. So one example is Chroma. So Chroma 1, HD, and Chroma Radiance are the two models I'm using the most for this project. You can find them on Hugging Face. In fact, it's a one-man project that is more or less open source because the training code is not available, but the dataset is visible. And we can, well, explore the dataset itself, and it's coming from Pexels. It's already 2 years back. And it's, we could say, an agglomeration of several categories of this website, Pexels, that you can go. And it's just a free stock photos website. So it has been downloaded. Then from these images, captions have been automatically produced by a well, specific model So you have these kind of files that are produced from the original data set. That's a very tiny, tiny, tiny part of it. And from this, all the process I spoke about just before has been done. So you can see here, it's just one part of the data set. So I let you imagine the size of it. That's why also sites like Hugging Face exist, so that we can use space for it, because having all of this in local is a challenge. It's another question. Models are more smaller than this because they are compressed. So let's go back before we finish to the project itself, because the idea was to say, okay, we are gonna make all these paths. So we saw a bit about this part. For the sound part, we are working on it now. I don't have really the time to speak about this, and it's a bit off topic, but we are working on a solution maybe. So poems, images, video. And so what about what we're going to show at the end? So I wanted to have a demo time, but I think I will be short on time. So I'm going to use the video. I hope you're going to see something, even if it's through Zoom. So the idea is to have this kind of, we could say, real-time multimedia sequencer. So we are going to use pre-made media, mostly, and we are going to mix them in real time according to the music. So here, as you can see, I can choose one poem, which is in fact made of different objects into a 3D real-time space. And from it, the idea is to be able also to move into space. So here, what you can see is a projection of the original image made with still another kind of model, which is used to make what we call Gaussian splatting. So you have one flat image that is converted to a depth map, a black and white depth map. And from this, an algorithm is going to project all the pixels into a 3D space and make them splats scattered around to reproduce the image in perspective, which is very interesting to us because it's still another way to express these pictures, to project these pictures. So we can then make them move, of course, and go back to another, well, 3D space made from the last image of the video. So it's one of the possibilities we are working on now. Another one that you're going to see just afterward is still different because, well, we think we can use all the stage picture behind the musician for some time, but maybe not all the time, all the 40 minutes. So we are trying to figure out different atmospheres, different way of, well, occupying the visual space, because the music is very strong, very disturbing. So the images should be here sometime, maybe sometimes strong, sometime more, well, we could say smooth or more discreet. And well, here you can see, you can recognize the video I've shown you just before with this, well, this deconstruction of space that is made by a model that is called Cosmos Predict from NVIDIA. That is also open source and that we can use to make image to video. And a last proposition is to use image sequences made from the image generation process, so that we can show us also it's not really a fake, but well, it's a reproduction of the genesis of these images. And of course, the idea is to be able to generate poems. And this time, this is made in real time because the LLM is pretty efficient and the calculation is very quick. So here, when I touch the button and the send prompt button, it really interrogates the LLM and I really get it from the LLM and I can use it in this visual space in real time and mix medias together. Yes. So the last, this is the last slide. So enhancing creativity. This is the subject of AI Secret. So I think that we are already creative anyway. So it's not about delegation. This is the important aspect of it. It's about exploration of the aesthetic potential of these technologies. But at least this is my position. So to use these AI in local environment, knowing how to code remains a necessary skill. Maybe you understood it with my presentation. So it must be taught, I think, to the current students. I was teaching programming languages and programming for the art and design until this year, so for more than almost 20 years. So it looks like it's still a required knowledge, maybe not in the same context, in the same fashion, but anyway. STEAM education also makes sense a lot in this place. So models are very unpredictable, very difficult to control. It's really chaotic. So maybe we can say that machines are still not artists because they lack the aesthetic intentions. This is where we still organize and control things. We choose, we change the parameters, we make selections, etc. So prompts gives a great importance to description, but well, it's not so easy to have, well, this description to produce the exact image you have in your mind. So yeah, these machines are not yet capable of imaginative thinking. We are here to do it. So yes, for the sound, I did not speak about it, but it's very complex because today there is no solution to use music as a prompt to generate an image. It's not feasible. So we have to, well, do it by ourselves. So yeah, we can say that the intelligence is not in the model, but in the original images. And it is inherited from the intelligence embedded in the images of the data set. It's not really in the result, but also in the global process. So maybe we can think about a way to have an aesthetic means of expression that could guide each other. Image that can guide some music production, etc. And maybe we will be a bit closer to the act of creation. Maybe we should not do that at all. Also, it's an option. And well, I think that a new generation of image processing has emerged. That's pretty clear. I spoke about a very, very few potential of it. We also have in-paint, out-paint, image-to-image, multi-reference generation, style transfer, LoRa fine-tuning, etc. So yeah, for new professionals and today's students, I think it's very crucial for them to master these tools. So educational programs should urgently incorporate these tools to respond to the reality of the future careers of these creative people. And we have still a lot of work to do. Thank you for your intention.